NASA's Perseverance rover recently discovered a very strange rock on Mars. The rock, which is comprised of hundreds of millimeter-sized spheres, has scientists scratching their heads to understand its origin. The rover discovered the rock in an area called the Witch Hazel Hill on the rim of Jezero crater. Here, a series of light and dark tone bands were visible from orbit, and just a week before, the rover had successfully abraded and sampled one of the light tone beds called Slants River. It was from this sampling workspace where Perseverance spotted a very strange texture in a nearby rock. The rock, named St. Paul's Bay, appeared to be comprised of hundreds of millimeter-sized, dark gray spheres. Some of these occurred as more elongate, elliptical shapes, while others possessed angular edges, perhaps representing broken spheral fragments. Some spheres even possessed tiny pinholes. So what geologic process could have produced these strange shapes? This isn't the first time strange spheres have been spotted on Mars. In 2004, the Mars Exploration Rover Opportunity spotted so-called Martian blueberries at Meridiani Planum. Since then, the Curiosity rover has also observed spherical features called spherules in the rocks of Yellowknife Bay at Gale Crater. Just a few months ago, Perseverance rover also discovered popcorn-like textures in sedimentary rocks exposed in an inlet channel called Naret Vivalis. In each of these cases, the spherules were interpreted as concretions, features that formed by interaction with groundwater circulating through pore spaces in the rock. However, not all spherules form this way. They also form on Earth by rapid cooling of molten rock droplets, formed in a volcanic eruption, for instance, or by the condensation of rock vaporized by a meteorite impact. Each of these formation mechanisms would have vastly different implications for the evolution of these rocks, so scientists are working hard to determine their context and origin. St. Paul's Bay, however, was float rock, a term used by geologists to describe something that is not in place. As a result, it's missing context clues that could explain its strange texture. It isn't just the geologic context that's missing, either. Something caused the rock to move from its original location, and that movement could reveal insights about Martian geology. Maybe this rock formed when a meteorite struck Mars, vaporizing rock before it condensed into the little granules. If this was the case, the rock could have originated far from its current resting place, and it could reveal how meteor strikes transport materials on Mars. According to NASA, it's also possible that the rock rolled down the slopes of Witch Hazel Hill. It may have originated from one of the darker layers on the hill that scientists have detected from orbit. Closer study of Witch Hazel Hill could tell scientists what those darker layers are made of. If they're similar in composition to St. Paul's Bay, it could indicate a layer of volcanic activity, an old meteor strike, the presence of groundwater in the past, or something else entirely. Rocks like St. Paul's Bay provide important clues about how Mars has changed over time. Understanding their formation and transportation can reveal complex interactions between water, rock, and geologic forces on Mars, which can help answer whether the planet could have harbored life in the past. If Witch Hazel Hill once had groundwater, some of the rock samples Perseverance has been collecting might contain fossilized microbial life. NASA's Mars Sample Return mission, currently planned for sometime in the 2030s, will scoop up these rock samples and return them to Earth for further study.